Solving right triangles. As you can see, I already have drawn out a general right triangle. And what I want to point out before we get into the mechanics here is the naming convention. When we're solving right triangles, we're generally going to be looking at triangle ABC with a right angle at angle C. So we have a triangle with our three vertices named as A, B, and C. And what I want you to notice on this triangle, the side opposite angle A is named as length little a. The side opposite angle B is named as length little b. And the side opposite angle C is named as length little c. That convention is something that we will keep with in working with triangles, so that if I simply tell you that we're looking at a triangle where, say, angle B is 50 degrees and side little b is 28, then I don't need to include the picture for you to understand what that means. But to solve the triangle means to look at this diagram, recognize that we have this angle, 50 degrees in this case. We have this side, 28 in this case. We know what angle C is, right? It's a right angle, that's 90 degrees. And then that leaves angle A, side little c, and side little a that we still don't know. Finding angle A is certainly the easy part, because I know that A, B, and C together have to be 180 degrees. The three angles of a triangle total to 180. Solving that, not too terribly challenging. I get that A itself is 40 degrees. Clearly the picture I drew here is not to scale, but that's okay. I've gotten that A is 40 degrees. And I'm just going to make this little tracker over here where I can mark down everything we solve. And let's clear to some empty space so that we can keep working, right? Yes, I'm erasing it because I only have so much screen to work with, but if you're working on a page, you can probably just go a little bit further down the page and keep working. All right. So now we have a choice. We can either solve for little a or little c. I'm going to go ahead and solve for C first. Now, looking at this diagram, I notice that C is the hypotenuse of the triangle. And even though I know what angle A is, for safety, I'm going to go and look at the angle that was given to us in the first place. Calculating the third angle of a triangle is not particularly challenging, but if by chance you make a mistake, then the mistake will carry with you. So it's a good practice whenever you can to go back to the thing that you know. So I'm going to look at angle B, side little b, which is the side I know, and side little c, which is the side I said I was going to solve for. Well, compared to angle B, that's the opposite side and the hypotenuse. And the trigonometric function that relates the opposite side and the hypotenuse is the sine. Right, so sine of angle B is little b over little c. Multiply both sides of the equation by c, and divide both sides of the equation by sine of b, to get that C is little b divided by sine of b. We know that little b is 28. We know that angle B is 50 degrees. So if I grab out my calculator, I make sure that my calculator is in degree mode because my angles here are in degrees, and I type in 28 divided by sine of 50. My calculator is happy to spit out that this is, I guess, round to the nearest tenth, 36.5514, etc. I'll call 36.6. Pay attention to how instructions are given. Very often the problem will tell you how to round. All right, so that takes care of side C, which means that the only thing left is to look at side A. And again, now that I know sides B and C, I could use the Pythagorean theorem. That would certainly work. But whenever I can, I want to go back to the things that were given to us. Because when I calculated this value of C, I rounded. And because I rounded, that rounding introduces an error in the value. It's not a lot of an error, but it is some error. And so if I use that value to calculate A, the error will propagate. A little bit of error in the first step will turn into a little bit more error when you have to round again, and a little bit more when you have to round again. So to be safe, to make sure that I'm not making a mistake from rounding error, to make sure that I'm not carrying a mistake I made in the calculation the rest of the way through, I'm going to go back to this information that was given to me. Angle B, side little b, and side little a. Compared to angle B, we have the opposite side and the adjacent side. That's tangent. Multiply both sides of the equation by little a. And divide both sides by tangent of b. Once again, fill in all that information. Make sure your calculator is in degree mode. And punch in 28 divided by the tangent of 50 degrees I get 23.4947, etc., which I'll round and call 23.5. Using the triangle, using the trigonometric ratios to find unknown sides, to find unknown angles, and just continuing the process to see what you have and how to use it to find what you need. That's the idea of solving a right triangle.